between applications and IT out of the equation and say, here's the data, right? You have 250 applications, and half of them are running on the wrong tier. And you can save your company millions of dollars if you position it on the right location. So that's something I could really use your help with. And being that they're a North Carolina company, that'd be great. Is there a question in the back? So unfortunately, I couldn't hear a word you said.
Okay.
So give me the nutshell version.
In a nutshell, when I look at this application, I'm just curious. Do you look at it to take it one step further from a security perspective when it comes to auditing along with disaster recovery and business connectivity?
Yep.
And would you sell that as another enhancement in regards to third platform?
So the tool allows you to identify applications that are logically grouped together, right, and put them in the security zones, and maybe they're not in security zones. Maybe you don't even know that there's dependencies. But I think, so the real answer is, this tool is a great way to have business discussions with the application teams and the business teams, the people that write the checks, and then follow up with security products, disaster recovery products, and new forms of infrastructure, like EMC Info Archive, and like what I'm about to show you. So what I'm about to dive into now is, on the right here, you have a picture of modern applications. How do we help our customers build them? And then, what is this third platform infrastructure? Let's take the mystery out of what it is and talk about specifically what are the building blocks that you will find yourself assembling in the lab as you build this infrastructure, and how is it going to interoperate with what you currently have? So let's step through that. And I forgot, I actually added, no one's ever seen these slides before. I'm trying them out on you. This is the way adaptivity works. They say, listen, there's 5 elements of any business value chain. There's a marketing and sales element, there's a service element, there's internal operations that complement the front office work, and on the back end, you've got inbound and outbound logistics. And customers run applications that perform a lot of these business functions. And so you can actually map them to the part of the business that these applications are trying to address. And then once you have that, you can take those applications and associate them with compute, with infrastructure, with an information lifecycle. So in general, you can say anything on the edge of marketing, service, sales, and internal operations is likely transactional in nature. You can start making some assumption of these applications and what are their CPU, memory, and storage and network needs in general. And you can model that mathematically. And so then you can say, well, I mathematically understand what this application needs, so I can map it, therefore, to some sort of underlying IT capability that it needs. And it may not be exact, and you can work with a customer on changing that based on their particular environment. So how do we build this new third platform infrastructure? How do we bridge to it? Let's get started. The first thing you need to think of, a third platform infrastructure should essentially be a data lake, where you're bringing together and centralizing all of your data for analytic purposes. And the foundational technology that most of our customers are starting to explore is the Hadoop file system. Why are they exploring the Hadoop file system? Number one, they're looking at the data volumes and saying there's too much data to store on my expensive mission-critical tier. So I need to try out something like commodity storage. And the Hadoop file system is open source. So I don't have to pay for the file system technology either. I can download it and install it on that commodity. But the big reason I believe that Hadoop file system is so popular you can give the analytic algorithms to the file system. So instead of dragging all that data up to an application, the data stays in place, and the algorithms are given to the file system, and they run and distributed in parallel. So that solves a big problem that we have with the current IT infrastructure. So we're seeing more and more customers begin to buy commodity storage, download open source, and run their algorithms, which is bad for us, right? So what we're saying is, listen, you got to think beyond the experimental phase and actually architect the Hadoop file system, and you should put an in-memory data grid on top of it. Because you should know that it's very likely, based on business need, that you're going to have to do streaming real-time analytics and combine that with historical disk-based analytics. The big example that we have is Vodafone in the UK. They had problems with dropped calls. At the end of the month, they would go to their IT infrastructure, they'd run a report and say, we had X number of dropped calls, and we have Y number of lost customers. So with their IT infrastructure, 1 month after the fact, they could see how much money they lost. With this type of infrastructure, they could write a new class of applications which could, in memory, real time, recognize those dropped calls, extract a cell phone number, go down to the disk layer, and very quickly in parallel run a query and generate a risk score for that customer, and then immediately turn around and text them and say, sorry about that. Can we reconnect you at no charge? Or can I give you a discount, right? And build up that loyalty and that personalization that's not possible with their current infrastructure. So this solves a lot of analytic problems. It introduces customers to the fact that don't just play with HDFS, right? We have products in Pivotal, Gemfire, which is a very robust in-memory data grid. It's used by the London Stock Exchange, so it's robust and it's reliable. And we've actually combined HDFS with our products so that you can drain from one to the other and combine those real-time streaming analytics with historical data. So that's building block number one, HDFS in-memory data grid. Building block number two is really an offshoot of the fact that Gemfire runs in server memory. So they're storing data in the server. And that's the second industry trend. More and more customers are starting to either kick the tires or deploy server-based storage. And the question is, how can our customers experiment with server-based storage, whether it's using Gemfire memory-based or it's using non-volatile solid-state or spinning disk drive at the server level? How can they horizontally scale that out? But also, how can they get the same level of data services, the comfort level that they have buying our disk arrays to do backup and recovery and replication and mobility? How can they take all that trust and all that intellectual property, how can they bring that up to the server level and then scale that out horizontally? So again, this is meant to tell the customer, don't be too hasty in deploying HDFS and server-based storage and all those things without considering protecting your valuable enterprise assets. And so we tell them, what is EMC doing to solve this problem? Well, we're a federated company. We have Gemfire and Pivotal, but we have VMware vSAN. So if you're a VMware customer, you can now claim all the storage in the server, whether it's solid state or spinning disk. You can pool it together and you can provide it to applications. And if you've been using VMware already, well, you already have VMware's backup and recovery, their mobility, and their replication. And they've applied that trust to their server-based storage. So if you're a VMware customer, we've got you covered. If you're not, or if you're sharing your infrastructure between VMware, OpenStack, and Microsoft, we've got a